with all the talk right now about whether gene mutations are random or somehow controlled by underlying processes, it appears scientists have found good reason to think that there are underlying processes and that the process itself may not in fact be random, which has always been a central tenet of evolutionary theory for one reason or another. It tends to be mostly spoken about in the creation evolution debate as a sort of a nail in the coffin argument for atheists. And then Christians come back and say, no, they are not random. It's God that does it, and they're wrong too. I repeat that one a lot because it just gets to me. I don't know why. Both can see that, or can't see that maybe there's more to things. Anyway, there's been a lot of discussion also in recent years about survival of the fittest and what that means. And ecologists and scientists have proven that it's not just the fittest for their own survival in terms of being the most fierce, eat or be eaten kind of idea. That's certainly a factor. But they're finding that the more successful trait is cooperation, where perhaps an animal sticks to its own niche, treats others in adjacent niches with, quote unquote respect, not respect as we think of it as humans, but, live and let live kind of idea across species and niches, unless they intersect as predator-prey relationships or some other kind of resource competition. So natural selection has always meant random gene mutations, and certain ones out of the billions that happen randomly become advantageous for that species to survive better, and those random mutations over millions of years combine into a form. But a form that has function, or a form in function, and this is where the lines get blurred, because there's a transaction going on between the species that's evolving and its cohort species in the niche. Like, those species are evolving as well. And so let's say you have one plant that lives next to another plant. Plant A gives off some chemicals that plant B does not generate on its own and benefits. And plant B does the same with different chemicals to plant A. This is just an example. As more of plant A grows around plant B, if certain of those plant A's have additional chemicals or certain mutations that plant B also likes, then plant B will go toward and nourish the desired features of the plant A specimens around it. It'll make that subset of plant A more healthy, better productivity, and that subspecies of plant A will begin to become the norm, while the other subsets of plant A that are less beneficial to plant B will fall away. I think that's how we can say it. Maybe it's kind of complicated, I don't know. But in that sense, plant B is selecting for plant A. So it's not just, I mean, yeah, natural selection is how this would be put. As we describe the process in nature, it's natural selection, but it's transactional. And so plant B has impact and direction on how plant A goes in its evolutionary path, which is just like what we talk about with special selection, that humans can select consciously for certain features that are desirable and start to cultivate plants and animals according to our liking. There's the only difference there is the consciousness and the action on behalf of the humans. But both are selective and in a transactional way, like one species to another. And I think that's how we see all of nature working. Like every species is evolving on its own, but only within its transactional functions with its surrounding entities. So each entity doing this is how coevolution exists, and whole habitats are created this way. It's incredibly beautiful. So even if genetic mutations were random, it does not mean evolution is random. There are guiding principles, and that's a beautiful thing too. That's all I think. Well, let me think.